The Fibonacci sequence is a series of numbers seen in nature and used in design. In Python it's used in many areas. It's used as an example to show how to use recursion, but you can use it with a for loop, a while loop, use it with a list, a generator. It's even used when explaining dynamic programming. So what is the Fibonacci series? Let's see. Let's look at this Fibonacci sequence, which is a series of numbers. Fibonacci sequence is a series of numbers with the pattern of each number being the sum of the previous two. And we've seen this in nature, and as I said before, we can see this is an example of how it's used in design. But what about Python? Let's imagine we've got we want to find the 10th number in the sequence. So we've got n equals 10. We could choose any number, and let's say n equals 10. Now, when we've got a low number, so if n is less than or equal to 2, for example, we know that the answer is going to be 1. Now, what else do we need? So let's imagine if we're going to use list. Let's say we have a list, and in our list we want to append the list last number and the number before that. So that's a list and a list minus 2. So we can append those numbers to a list. Now we start off with the list equaling 1 and 1, because those are our numbers when the n is greater than 2. So now we just need to add a for loop where I is in a range of n, and we've taken off the first 2 in the range. So let's use the for loop. So now once we do the for loop, when we come to the end, we can print our list. The last digit is going to be minus 1. So let's print that. And we want a list to equal 1, 1 rather than a 1, 1. And we get our answer 55. So we've just added the 2 numbers in the list, the 2 last numbers in the list, and added that at the end of the list. So that's a simple way using a for loop. Now here's an example where we're going to use a while loop. So the code is virtually the same. We've got x and y is 1 and 1. We've got a count. We've got n. If it equals 1, then we just say we can print 1. Else, well, now we've got a while loop. So while the count is less than n, we've got our answer. So we've got our 2 numbers x and y, and basically we're going to add them together and then change them so the first number equals the second number and the second number equals the sum, and then we move through our while loop. And if we run that, you can see that we've got 55, the same as our previous example. So in this example we used a while loop, not a for loop, and we've not used the list in this example. Let's see a similar example, but let's use a generator. So we have the code where we had the while loop, and we had z equals x plus y, x equals y, y equals z. And now we can do that again. Let's just take this code out for the moment, comment that out. So here we've got the generator where we yield x. So we have a for loop that just goes through the amount of n's that we want, and then we yield X, so that increases, and then we've got the same code as we had before. Now we don't need to do that exactly the same. We could actually have the X and Y equals Y and X plus Y. Now X and Y are added together first, and then X equals Y after. So that is a bit confusing, but essentially that does the same thing as these 3 lines of code. So if we print that, we can see we have the sequence that goes up to, in this case, 34. So we perhaps need to add one. Let's say we add one to take out the 0, so then it can go up to 55. Okay, or actually what we could do is make X and Y equal 1 to start off with. Right, that's better. So we don't need the 0 at the beginning, and there's our sequence of 10 numbers in the Fibonacci sequence. So that's not very common. Perhaps the most common method used, and the one that we see people use as an example, is to explain recursion. So I've never been a fan of recursion, we haven't had a video on it, but here we've got Fibonacci and n, we've got a function. So we can call that function with n, which we know is 10. And if n is less than 2, we're going to return n, else. And what we're doing here is we're calling the function twice. We're calling the function Fibonacci of n minus 1, and we're adding that to what the function is of n minus 2. So this recursively calls the same function. So if we run that, let's run that. We haven't got an answer. Let's say answer equals, and let's print that answer. So print answer, and we should see that we get 55. So this seems smaller amount of code, seems quite straightforward. So recursion, yes, it works, but what's the problem? Why is this example used to show recursion, but why am I not a fan? And the answer to that is that we're calling the function twice. So what happens is in Python we have to keep storing the answers. So when we keep calling the function, we're using up a lot of storage. Here's a website where we see this code, exact same code compared to another form. And if we move down the page, we can see that one of them is 1,500 times worse than the other one. So recursion can be bad, not very efficient, unless you use certain techniques, and that's where dynamic programming comes in. So what we're saying is that we've used the Fibonacci sequence of numbers. We did a simple for loop using a list, which was how we would do it intuitively, naturally. Then we showed a while loop example, then a generator example, and now what seems like the simplest, this recursion, the simplest in smallest amount of code, is a bit more complicated because it's calling itself. The function is calling and calling itself twice. And this method is not efficient. So the recursion can mean that we overuse our resources. So how does this change with dynamic programming? Let's explain that next. Well, here's a video that's explaining the Fibonacci sequence, and when we're looking for the number 7, the 7th number, we've got to work out the 5th and the 6th. To work out the 5th, we've got to work out the 3rd and the 4th. To work out the 6th, we've got to work out the 4th and the 5th. So we end up duplicating a lot of work. So this makes it exponential, which is not efficient. So the way that we can get around this in dynamic programming is using a technique that when we calculate say the Fibonacci number 3 is we save it in a dictionary, and Fibonacci number 4 we save it in a dictionary. So when we calculate it the first time, we store that value. So rather than calculating it many times, we just calculate it once and store it in a dictionary. So when we use this recursion, instead of duplicating a lot of work, we can use this memorization to store the values in a dictionary and call them, rather than all of this repeated work. So that's a way of using the problem, like subproblems, which is dynamic programming, using the subproblems together to solve the overall problem. So what does that look like in code? So let's return to our code. We had our recursion, which worked but wasn't very efficient. Now let's comment out our recursive example. Now this memorization, now we're using dynamic programming. So let's call this, so we've got our answer equals dp with our n, which was 10. We need to make sure our recursive program is still available. Let's run this, and we need to print the answer. So we've got 55. So let's explain this now. So with memorization, we've got our dictionary, and if our answer is less than 2, we return that. But now we've got our recursion, but if we know the answer, we put it into the dictionary. So rather than keep calculating it, we memorize it, if you like, and then when we need it inside the recursion, we already have the answer. So when we run that, you can see we still got our same answer of 55. So we have recursion, but here we keep the answer so we don't duplicate the work. So this is a lot more efficient than just using the recursion. So this is a form of dynamic programming where we store the value in the Fibonacci sequence. So let's just try a different example. Let's just try it with 9. So we know the answer is 34. We've got our original code that we created. We've got our while loop. We've got our generator example. That's going to print the list. Then we've got our recursion, and then we've got our efficient recursion using memorization. So if we run that, we've got our 34, 34. We've got our list of numbers 34, 34. So those are using the Fibonacci sequence. We're creating it using a for loop with a list, a while loop, a generator, recursion, and recursion, but efficiently using dynamic programming with memorization. So that covers a lot of the example of the Fibonacci sequence of numbers. Well, we covered a lot about this Fibonacci sequence, this series of numbers where we add two numbers together to form the next in the series. It's quite interesting, used in nature and design, so there's quite a few web pages and videos that are worth looking out if you're interested about this Fibonacci sequence, and we'll put links in the description. Okay, well, I hope you enjoyed that. It's slightly a bit different from normal. If you're looking for the exercises, I mean, we may do some, but perhaps you can just practice the different types of writing the same code using the different types of loops, generator, and even recursion, and even using the dynamic programming. Let us know which version of the Fibonacci series, which Python code you preferred. Leave a comment and tell us. Okay, don't forget, if you haven't already, subscribe. Please like the video, it really does help us and makes us happy. And if you click that notification bell, you'll find out when we are releasing the videos. We're coming to the end of the series of the iter tools, the short videos. Probably won't do that many short videos, but if it brings in new viewers, then we'll have to keep doing it. Okay, hope you enjoyed this video. Let us know if you have any requests.